Today's lesson is section 1.6, Relations and Functions. Essential question: how can I identify the domain and range
okay,
of relations and functions? So we're going to talk about both.
Relations and functions. Okay.
All right, so if we look at the mapping, we're going to talk about it briefly here.
Yeah, we'll go into more detail.
Yeah. So basically what a mapping means is we talk about domain and range. Domain is your input, range is your output. Domain goes with X.
Oops. Input, you said? Okay.
Range is output and goes with Y.
Okay. So if you get ordered pairs, like Miss Young said, your domain is your X values, so the 2's, and then your output, your Y values, A, B, and C. And that's why she put them there.
Exactly.
Okay.
So let's go down and now let's talk about what is a function.
Okay.
Well, it says, notice the word relation.
Okay.
It's a relation in which the first coordinate, your X value, is never repeated.
Never repeated. That's the main thing you want to take away. So your X number can never be the same.
That is a function.
Then it's a function. Okay.
But what if my Y value was the same? Is that okay?
Yeah, that's okay.
Right. So I want you to make sure you pay close attention to that.
Okay.
So each X value domain has only one matching Y value in the range. That determines what a function is.
Okay.
So let's do some examples for this. So for example, let's set up a bunch of ordered pairs.
Okay.
1, 3, 2, 4, 3, 7, and 8, 6. The question is it a function? Yes or no?
All right.
All you need to look at is your X value.
All right.
Does your X value ever repeat?
So we have 1, 2, 3, 8. Never repeats.
The answer is yes.
X never repeats.
So it is a function.
Yes, it's a function. Awesome. That's easy enough.
Yeah. How about we move on and we'll see others that aren't functions in just a little bit.
Okay.
So here we go.
Yeah. So we're still talking about it. So this is not a function because here our X value, is going to both A, B, and C. If we wrote it as an ordered pair, it would be 2, A, 2, B, oh boy, and then 2, C. So as you see, the X value, or your first number, or your first thing in the pair, is repeating. Here's what I like to do.
Yes.
Okay? I think of a mailbox. Ready? We got a mailbox. We got a piece of mail. Here's my mail. Here's my mailbox. So my mail is X. My mailbox is Y.
Yeah. Can
I ever take my piece of mail and put it in 2 different mailboxes at the same time?
No.
Could I ever put this same piece of mail here and here?
Absolutely not.
No, unless I ripped it up and then the federal offense, and oh, we don't want that.
Correct.
So this is not a function. Okay.
I like that analogy.
Now, here's my question. Can I take different pieces of mail? So I've got this piece of mail, and I've got this piece of mail, and I've got this piece of mail. Can I put all 3 different pieces of mail in the same mailbox?
Correct.
Yeah, we get mail all the time. We get more than one piece. That's okay. You can take different pieces of mail. We'll call this mail piece 1, mail piece 2, and mail piece 3.
Right.
That can all go in the same mailbox.
Correct.
So that is, yes, this is a function.
I like that.
So that's how I remember it.
Very good. Very good. Okay. So let's go down and look at example 1. However, we decided we're going to wait for example 1
we're going to
for
do the class because it's a lot more fun.
Example 2.
Okay.
So now instead of giving you numbers, we're going to use words. So we're going to determine whether each relation is a function or not.
Okay. So yes or no?
Right. From players on a basketball team to their points scored for a specific game.
So players are first.
Yep.
And then the points
are second. So players is our X, points is our Y.
Got it.
So let's just think of some names. Okay, Adam.
Oh, that didn't look like a Y because
there we go.
Points. Sorry.
So let's write Adam. And Adam's going to score 17 points. There's our first ordered pair.
All right.
Corey he's going to score 23 points.
Okay.
Justin is going to score 81 points. And Tim, let's say, he is going to score 17 points also.
Okay.
So is that a function, yes or no?
Well, I'm going to look at my first thing in my ordered pair and see if it ever repeats.
Right.
I have Adam, Corey, Justin, Tim. Nope, their names never repeat.
The answer is yes.
So it's yes.
Notice 17 does repeat.
Yeah.
That is okay. Your Y values can.
Only look at your X's
Correct.
to determine.
Let's do another one.
All right.
From car models to car colors. So let's say Ford. I like
All
Ford.
Right. I don't.
All right. Well, okay.
That's okay.
Ford is blue.
All right.
All right. That's one pair. And notice it said from car models to car colors. So car models is X, car colors is Y.
Okay.
How about Toyota? I really like Toyota.
All right.
And my Toyota is also going to be blue.
Okay.
Well, let's do Ford again.
Okay.
And this time my Ford is going to be white.
Nice.
And let's do Ford just one more time for the fun of it, because Miss Boyd doesn't like Ford.
Yeah.
My Ford's going to be yellow.
Ooh.
Is this relation a function? Yes or no?
Well, I'm going to look at my X values or my first thing. See if anything repeats. Ford, Toyota, Ford. Oh, it's the same thing, so it's not a function.
Correct, because Ford repeats.
It's
Blue?
okay that the blue's repeated.
Yep.
But we can never have our first thing repeat.
Correct.
Okay.
Next one. From day of the week
Okay.
to the number of hours in school. Day of the week is our X.
So Monday.
So we'll do Monday. Well, we're in school actually 6.5 hours.
Okay.
And Tuesday, 6.5 hours. And Wednesday.
6.5.
And Thursday.
Thursday.
6.5.
6.5.
And Friday.
6.5.
From the, what is it? From days of the week?
Saturday.
Well, we're not in school on Saturday, so that's
None.
0. And Sunday is
none.
and technically Wednesday, some of you may argue with us because it's late start. It's not technically 6.5, but that's
Even
okay.
if it wasn't, we could
Right.
say 5 and we'd still.
Right. So is it a function?
Again, we look at the first ones, only the X's. If they ever repeat, it's not a function.
They never repeat.
They never repeat.
The answer is yes.
Yes, this is a function.
Let's go on to the next page. These will be really quick.
Yes.
We're going to determine, are the relations functions or not? Let's look at the first one. Do any of the X's repeat? 1, 2, 3, 6. The answer is yes. That quick.
Yes, it's a function because they did not repeat.
Let's look at the next one. 3, 4, 6, 12, 13.
We're good.
Again, it's a
So
function.
yes,
The X's
function.
did not repeat. And the last one. 2, 3, 5, 2.
Oh, the twos repeat.
It's
So this is
not
no,
a function.
Not a function. That's easy enough.
Easy. All right. Example 4, we are going to do now with you. What if you have a graph?
Okay, and they only give you the graph and points.
Yep.
Okay.
How do you find the domain and the range? And then how do you decide if it's a function?
Okay.
So the first thing we have to do is label all of our points.
Yes.
So that's what we're going to do first.
Okay. So this one over here, we go back 1, 2, 3, and up 1, 2, 3.
So that's
negative
negative
3,
3,
3.
3. Or wait, is that 1, 2, 3, 4 actually?
Oh boy. All right. Sorry, it's hard to see. All right. So
that's negative 4,
comma
3.
3.
Right.
Okay.
The next one, that looks like
Negative
2
2,
up
1.
1.
So negative 2, comma 1.
The next one is
Here, 0.
right, and down 2, 0, negative 2. This one is over 2, up 1, and
over
1, 2, 3, 4, up 3.
Okay.
There's our points.
Okay, so I'm just going to quick write them out. I got oh boy. Negative 4, 3.
Try that. Yep, negative 4, 3,
I
and
have
negative 2, 1,
Negative 2, 1.
and 0, negative 2,
0, negative 2,
2, 1,
2, 1,
and 4, 3.
and 4, 3.
So
Okay.
before we determine if it's a function, let's look at the domain.
Okay.
What is the domain?
Domain are X values.
Right. So we can list
So,
those.
negative
Negative 4, negative 2, 0, 2, and 4. And the range are our Y values,
Okay.
which will be 3,
3,
1, negative 2,
1, and 3.
Correct.
So we just look at our domain. Are any of them repeating? No.
No.
So then is this a function?
Yes.
Yes.
Now I want to specify one thing before we go on.
Yes.
When you look at the range, notice we repeated the 3s and we repeated the 1s.
Yeah, that's
Technically, it's okay, but you don't have to.
Oh.
So I want to give you one other way you could have written
Right.
this is 3.
So 3,
1,
1,
negative 2.
2. You know the 1 repeats, so you don't have to write
You
it
do
again.
not.
3
And-
repeats, you
And
don't have to-
technically, what's in red there, that's the way you want to write your range. You
Okay.
do not want them repeated because you don't need to do
Right,
that.
because it doesn't matter. Okay.
All right, so let's go on to the next page, which is an example we are doing in class. And one more thing we're going to talk about.
I love this.
I do too.
So easy.
So you want to start?
Sure.
All right.
So the vertical line test basically just says take your graph, which we have this graph, this red graph, and you just take a vertical line. So a line straight up and down. So think of your pencil. Just hold your pencil straight up and down. You're going to move it across the graph. If it ever touches the graph in more than one spot at a time,
Yep.
then it's not a function.
Right.
If it only touches it at one spot every time you move it, then it is a function.
Correct.
So here I moved it, it touched one spot, keep moving it, I touched it one spot, so it's still a function.
Correct.
Here, if I move my pencil over, it touches my graph, that red part, twice on that vertical line, so it's
It's
not,
not a function. So let's do an example 6 here. Let's
Okay.
go through this. Let's look at the first graph.
Yeah.
So,
So
we
if
can
I
just,
were to take a line,
and anywhere. Doesn't matter
Draw it.
where you draw it.
every time I draw a straight line, it's only touching my graph.
Once.
One time.
So the answer is
So this
yes.
is yes, this is a function. All right.
And on the next one,
If I drew a straight line, oh, right away,
Right
I see
away,
it
we can
touched
stop.
here and here.
the answer is no.
It doesn't matter that those lines aren't connected, but they're both red, so that means that was our
Correct.
graph. So
Yes.
this is a no.
And the third one.
If I drew a line anywhere, touched in one spot, touches in one spot,
And if we do it,
touches in
yep.
one spot.
It's always going to touch in one spot.
So,
It's
yes.
yes, it's a function.
Nice.
That is it for today. If we go to the next page, there are your video questions. We will see you tomorrow.
Bye.